Hey everyone, I'm Pranshi Agarwal and welcome back to my YouTube channel. Today we will be solving today's Leetcode daily challenge, which is map of highest peak. Okay, so let's see what is this question and how we can solve it. So in this question, you are given an integer matrix is water of size m cross n that represents a map of land and water cells. Okay, and if the value at that of a particular index in that matrix is 0, then this is a land cell, and if the value is 1, then this is a water cell. Okay, so let's suppose if we have been given with some matrix 0 0 1 1 0 0 0 0 0, then these two cells are water cells and the rest are land cells. Cool. Okay, so you must assign each cell a height in a way that follows these rules. Okay, so let's see what are these rules. The height of each cell must be non-negative, and if the cell is a water cell, its height must be 0. Okay, so let's see the example. So this is an output matrix and the input matrix is this is water, which is 0 0 1 1 0 0 and 0 0 0. So these are land cells, sorry, these are water cells and the remaining are land cells, and we need to create an matrix, height matrix, in which the height of the water cells must be 0. Okay, so let's create it. So the height of water cells must be 0. Okay, and the height of all the cells must be greater than 0. Okay, but right now we don't have information that how we can fit these remaining indexes. Let's read the question further. And any two adjacent cells must have an absolute height difference at most 1. Okay, a cell is adjacent to another cell if the former is directly north, east, south or west or of the latter. Okay, so now this is the information how we can fit the remaining indexes. So the height difference between any two adjacent indexes can be at most 1. Okay, so from which value we can fit this index? Either -1, no, the value of height of all these cells should be greater than 0. So -1 is discarded. 0, yes, because the height difference is 0 and we have been given that it should be at most 1. So 0 should work, or 1 will also work, right? And this is also the adjacent cell of the above, so we can also fill it with 0 or 1. Okay, now find an assignment of heights such that the maximum height in the matrix is maximized. Okay, so we need to finally create an height matrix in which the maximum height in the matrix is maximized. Okay, so let's see how we can fill this. Okay, so let's suppose if we fill it with 0, right? So, and we also fill it with 0, and we also fill it with 0 0 0 0 0. Cool, it will work, but the maximum height in this matrix is not maximized. That's why we will take the maximum value at every step. Okay, so see, here we are two starting points, and what we need to do, we need to look for its neighbor in the east, west, north and south, in all the directions, right? So what we can say that it is a kind of BFS traverser, because what we do in a BFS, that we have been given with a source node, and first of all we need to look for all of its neighbors before moving further, right? So this is a BFS, and as you can see in this question, like there can be more than one water cells, so there can be more than one starting points. So what is this? It is a multi-source BFS, right? Okay, so let's see. First of all, we need to create a queue, right? We will be creating a queue, and in the starting we will be pushing the water cells. Okay, let's first write the indices. Okay, so first we will push 0, 2 in our queue and 1, 0, right? These are two water cells initially we have. Okay, and we will also we will need to keep the track of visited cells, so that we can check whether we have visited this cell earlier or not. Otherwise we will keep on updating them again and again, and we will get stuck in an infinite loop. Okay, so let's suppose this is our height matrix, and initially we are initiating all the cells as -1. Okay, and while pushing the starting water cells in the queue, we will initialize them as 0. So okay, it will work. Okay, now let's start iterating in our queue. First of all, we will pop out this first index from this first cell from our matrix, sorry, from our queue, and iterate on all the neighbors of it. Okay, so what are its neighbors? 0, 1 and 1, 2, right? Okay, cool. And we will update its neighbor with a +1 value of the current cell. So what will its value become? Its value will become 1 and 1, right? Its value will become 1 and its also will become 1. Cool. Now we will pop out this 1, 0 from the queue and push its neighbors. Now it's and we will push the neighbors only if they are not visited, right? And its neighbors are 0, 0 and 1, 1 and 2, 0, right? And they are all not visited, that's why we have pushed all of them. And we will update their values in the height by +1 value of the current cell. Cool. Okay, now we will visit the next cell in our queue, that is 0, 1. Now we will iterate on the neighbors of this 0, 1 cell, but all of its neighbors are already visited, so we will just move forward. Now we will pop out 1, 2 from the queue. Now this 1, 2 and its neighbor is 2, 2. Okay, we will push it in our queue and we will update its value by +1, that is 2, right? And now we will again move forward and to the next cell, that is 0, 0, and all the neighbors are already visited, right? Yes. Now we will move forward 1, 1, all the neighbors are visited. No, this is one is remaining, that is 2, 1. We will also push it in the queue. We'll update its value by +1, that is 2, and now we'll move forward. Now 2, 0, all the neighbors of 2, 0 are visited, all the neighbors of 2, 2 are visited, all the neighbors of 2, 1 are visited. And now we have come to the end of our queue, and we have got our final height matrix as 1, 1, 0, 1, 1, 1, and 1, 2, 2, right? And as you can see from the answer as well, 1, 1, 0, sorry, this was 0 because it was the answer, I missed it. Okay, 0, 1, 1 and 1, 2, 2. So this is our final height matrix, right? I hope you got this approach. Now let's see how we can code it. So let's store the total size first, so that we don't need to write it again and again. And m is equals to is water 0 dot size, and let's create a result vector int result of size n vector int m comma -1, because we will be using it as also visited vector, and the value cannot be -1 in our final height vector. That's why I'm using -1 here. Okay, now let's create a let's start iterate. Let's create a queue pair of int comma int, and now let's start iterating on our matrix, so that we can first I is less than n, I plus plus for int j equals to 0, j is less than m, j plus plus. So that first we can initialize our queue with all the water cells. So if is water of I j equals to 1, then we will push it in our queue. Cool. Now we will start iterating on our queue. Why not? The queue is not empty. And now let's store the row. Queue dot front dot first column, queue dot front dot second, right? And we pop it. And now we will iterate on all of the adjacent neighbors. Okay, so let's create a del row vector -1 0 1 0 and del column vector which is 0 comma -1 comma 0 comma 1. Okay, now let's iterate on all the neighbors. I is equals to 0, I is less than 4, I plus plus int row is equals to r plus del row of I, and int call is equals to c plus del call of I, right? And if row is greater than or equals to 0 and row is less than n and column is greater than or equals to 0 and column is less than m, because these are the end conditions, so this it should satisfy this. And if result of row call is less than 0, it means it is not visited as it is negative. So what we will do, we will simply push it in our queue and will update its result. Result of row call is equals to result of the one which we are popping out, right? And finally we will return our result vector. Now let's try run this. What we have done, why it has given me TLA. Okay, so we have forgotten to initialize our result here also. Just a second. So result of I j should be 0 here, as we have initialized it with 1, so its height should be 0 if it is a water cell. Okay, now let's run it again. Oh, we have not initialized it with +1. We forgot to update it with +1. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. Now let's talk about its time and space complexity. As you can see, we are iterating on all the cells of our given matrix. So its time complexity, where we go of m into n, and for the space we are using this queue which is storing all the cells of our matrix. So its space complexity will also become big of m into n, why not considering the space of our result vector. So this way we have final space, time and space complexities. I hope you get this question. If you still have any doubts, then you can surely ask in the comment section. I will try to answer them. Till then, bye guys, see you in the next video.